All right, starting lesson 6.4, similar polygons. Similar, a big idea. All right, if the ratios of corresponding sides of two polygons are equal and their corresponding angles are congruent, then the two polygons are called similar polygons. All right, and the key idea is that the ratios of the corresponding sides are equal. All right, now the word blank is used to indicate that the ratios of corresponding sides are equal. All right, the word proportional is used to indicate that the ratios of the corresponding sides are equal. All right, so like below here we have this example. Are these figures proportional? All right, before we get into that, in the diagram, ABCD is similar to EFGH. Now the symbol for similarity is like the congruence symbol. There's a squiggly line, but with no equal sign below it. All right, that's all there is to it. Now, important, there are blank criteria that must be fulfilled in order for two polygons to be similar. There are two criteria. Now, the first piece of criteria that must be fulfilled is that you must have the statement of proportionality satisfied. In other words, all the ratios of corresponding sides are equal. So here I have AB. That should correspond to EF. And then I have BC, which should correspond to FG. And then I have CD, which should correspond to GH. And DA or AD, which should correspond to HE or EH. All right, that's our statement of proportionality. All right, first that has to be true. And then the next piece of criteria, the corresponding angles are congruent. So angle A should be congruent to angle E. And angle B should be congruent to angle F. Then you have C should be congruent to G. And D should be congruent to H. All right, if those two pieces of criteria are met, then the triangles or any type of figures are similar. Important, just like writing a congruent statement, the order of letters is important when writing a similarity statement. Using symbolic notation, one possible similarity statement for the above example could be, all right, let's start off from here. A, then I have B, C, D. So I would say A, B, C, D is similar to figure E, F, G, H. Okay, the order of the letters matters. Okay, that's all there is to that. All right, a lot of information here. If you have any questions about any of this, if it doesn't make sense, please make sure to ask. But we'll go into some examples, and hopefully it makes more sense once we cover those examples. Example 2, decide whether the figures are similar. If they are similar, write a similarity statement. Okay, let's see here. Are these figures similar? Well, this is 75 degrees here. These lines are parallel. So I have consecutive interior angles here, so that makes that 105. I have consecutive interior angles up here, so if that's 118, this is 62. Okay, same deal here. I have parallel lines. So if that's 105, this is 75. And if this is 62 here, this has to be 118. All right, so the criteria that all the angles are the same, or that they're congruent, has been met. Now let's look at the ratios. Okay, I have 20 right here to work with. And 20 should correspond to which side length? The 10. So that's 2 over 1. All right. Or 2. All right, let's work with another side. All right, here I have 12. All right, how do I pick the right side for the smaller trapezoid? Well, here's 62 and 118. Here's 75 and 105. 75 and 105. So I need to use the 6 here then. So that's 2 over 1, which is 2. All right, the ratio is 2 to 1, or 2. Let's keep it as a ratio instead of writing it as a whole number. So 2 to 1. And then we have, I have 14 over 7. That's a ratio of 2 to 1. And then I have 30 over 15. That's a ratio of 2 to 1. All right, so all the ratios of the corresponding sides are the same. So these two figures are similar. So let's make sure I write out the letters in the right order when writing my similarity statement. It's going to be J, K, L, M is similar to, okay, J corresponds to what angle? It's 105, so it's P. And then I go to K, K is 118, so it's going to be Q. And then L is 62, so it's R. And then I have S. All right, that's all there is to it. Now, if two polygons are similar, then the ratio of the lengths of two corresponding sides is called the scale factor. All right, it is a number that shows how much bigger or smaller similar figures are to each other. Okay, this is the scale factor right here in this example. 2 to 1, going from the larger figure to the smaller figure. All right, painting is similar to the wall on which it is hanging. Determine the scale factor and set up a proportion using the scale factor to find the length of the painting in feet. Okay, well, what is the scale factor? They tell you that the painting is similar to the wall. All right, here's the wall. All right, here's the painting. Okay, so here's the width. The width is 10 for the wall, and the painting width is 4. So I get 5 over 2. This is my scale factor. All right, this is what's going to help me figure out what the length should be to ensure that the painting is similar in size to the wall. All right, so I have 5 over 2, and that's going from the wall to the painting. Right? Or you could start off with the painting lengths and then go to the wall lengths. It doesn't matter what order you do it in, you just have to be consistent. All right, so I have 5 over 2 going from the wall to the painting. And now for the length of the wall, that's 15. And going to the length of the painting, I don't know. So L sub P. I cross multiply here, and I get 30 is equal to 5 times L sub P. So I divide by 5, and L sub P is equal to 6. All right, and that's all there is to it. We're done. So the length of the painting is 6 feet. And there's nothing else we have to do here. That's all there is to it. Example 4, the two polygons are similar. Find the values of x and y. Okay, we know that they're similar, so we know the angles are all congruent. Okay, this one's 90. This one's 61. This one's 116. So this right here must be equal to 93 degrees. All right, so I'm going to add 73 here. And y is then equal to 166. Done with that. All right, how about to figure out x? Okay, this is my 93 degree angle here. So I have 93 and 116, and x is that side length that touches both of those angles. So 93, 116, 5. Okay, so here I have x over 5. I'm going to set up a proportion. Okay, x over 5 should be equal to 6 over what value? All right, is it this side or this side? Well, here's my 93, here's my 90, here's my 93, here's my 90, so it's going to be 4. Okay, All right, now I cross multiply. I get 4x is equal to 30. I divide by 4, and x is equal to 7 and 2/4, or 7.5. Done. All right, if you have any questions, please make sure to ask. We're going to be working with similarity a lot from this point on. Begin the assignment.